Hi guys, Bioinformatics guy here with another video of the series Python for Bioinformatics. In this video, we will be talking about the modules. So apart from the basic functions, methods and objects, Python also provides a large variety of optional functions and methods. These functions and methods can be imported into Python by using the modules. So modules are basic Python script files which are present in the library directory, and this directory is created alongside the installation of Python. You can also download and import different kind of other modules which are not part of basic installation of Python, and then you can also use them. Module file is basically a Python script which contains the definition of the functions, and those definitions contain the doc strings, and doc strings explain the functionality and the basic purpose of those functions. So in this video, we will be talking about the basic use of Python modules and how to import them and how to use those functions. So let's get started. Okay, let's start with importing. A module contents are brought into the interpreter by a simple import state. The basic form of the import statement loads the module into the Python environment. It's gonna be just like import, and name is gonna be the name of the module. For example, the module OS provides an interface to the computer operating system. You can simply import it by import OS. Let's run this and it is imported now. As I already told you that there are a lot of Python modules already installed alongside Python installation. So in order to use them, we run the import statement, and what import statement does is that it imports that module name into the Python interpreter's library, and then you are able to use that function or the module. Sometimes you don't need to import everything of a module, and you can only import a few functions of that module. And this is gonna be very simple. Let me make it a bit bigger. We have to type from module name import name1, name2, name3. And we can import more than one module at a time. So let me give you an example of this. We can import from math import py and import remainder. Alright, let's run this and this is imported. Sometimes you want to change the name of the module that you are importing, so you can import it as alias. From math import factorial as fact. So now you will be able to use it as fact. If you want to import all the names, what you will have to do is to import or from math import and then use the star sign. It will import everything in the math module. So you should not be imported everything, because you don't know what names you are importing, and sometimes that the functions you have created might cause conflict. So it's always better to import a function and then use import as and use specific name for that function that you have imported, so that you will know that I have imported this function by this name, and then it won't cause any conflict in your code. Let me give you another example of the module sys. If you will import sys, then for every function you will have to write down sys.version, sys. The function name, sys. The version name. From sys import version, you will only have to type version and then you will get the version. See, you got the version. And if you will import only sys import sys, then what you will have to do is you will have to write sys version in order to get the version. I don't think so version is gonna work right now. Yeah, it is working because we have already imported that. So let's talk about the random module. Random module is a very useful module. So one of the functions that is most widely used in Python is random.randint. It will import a random integer between a range. So you will have to add two numbers as the arguments of the function. For example, random.randint 1, 4 will return 1, 2, 3 or 4. Both of the numbers are included, like 1 will also be included and 4 will also be included. Now let's write a function that will return a random base. Let's import from random import randint. Let's run this, and in the new cell let's define our function def, and the name of the function is going to be random base, and let's also make a RNA flag, and let's keep it by default as false. Alright, now we will return UCGA if RNA flag. Now if RNA flag is true, then it will consider UCGA, else it will consider ATGC, or you can write TCGA. Alright, then we have to select our, now here we will use the randint, RAND, randint, and we need from 0 to 3. So 0, 1, 2, 3, 4 options. Let's run this and see if the function is defined. Now it's defined very nicely. Let's try a few examples. Print, then random base, and over here we can run this. We got A, we got T, we got G, we got G, then we got C. Let's make the RNA flag true, or just write true over here. Let's run this again. Now this time we should be able to see a U once in a while. See, now we got the U. By using this random module, let's define another function that will return a random codon of 3 bases. Def random codon. We will also create RNA flag over here, and by default let's keep it false. Now we will use the previous function random base RNA flag plus. Since we need 3 codons, we will just sum these 3 times. Sounds good? Let's run this and see if this function is defined properly. This function is defined properly. Let's try a few examples. Print random codon. We got ATT, GTT, TGA, TTA. Let's turn the RNA flag true so that we will get the RNA codons. Now we got UGG. See, it's working very good. Now you might have noticed that how breaking down a code into smaller functions help us. We first defined a function that returned us a random base, and then we use that function in another function to get a random codon. So defining small functions is just like building up your vocabulary. You will define a small function, then it's gonna be added to your vocabulary, and then you can use those different functions to make out a huge sentence, or you can say that a huge function. So rather than making a huge function, it's always suggested to make smaller functions so that you can use those smaller functions in your upcoming future functions. Okay, now let's make a function that simulates a single base mutation. Let's name this function replace base randomly using. The name of the function is very long, but you will get to know why I'm naming this function like this very soon. And we will be needing a base sequence, and let's define a docstring as well. In our docstring, return a sequence with a base at a randomly selected position of a base replaced by a base chosen randomly from 3 bases that are not in that position. So let's see what is our position going to be. So our position could be anything. So we will use the randint again, and our position could be anywhere from 0 to the length of our base sequence minus 1. Why we are subtracting it? Because we know that result of the length function is gonna start from 1, and our randint is inclusive of all the numbers, so we are subtracting 1. Alright, this is gonna be our position, and let's add a short comment -1 because len is 1 past end. If you want to be sure about why we are doing this -1, you can just go into a Python interpreter or Python shell, and then you can see that what is the length. Then you can try importing from 0 to the answer that you get without the -1, and you will see an error. Okay, so our base is gonna be base seek position. So this is gonna be our base that we are supposed to change, and our total bases are gonna be TCGA. Simple. Okay, I was not supposed to run this because this function is not completed yet. So now we got to replace the base. We will replace the base by bases dot replace, and then we will replace our base with an empty string. Our new base is gonna be bases, and it's gonna be rand in 0,2. Okay, now beginning is gonna be base seek, and it's gonna be from 0 till the position. Let's add a small comment, up to position, and then our end is gonna be from base sequence, and this time we will start from the position +1, because we have our beginning is still position. Now we need to move to the next one, and if we will keep this empty, we will get all of the rest of the stuff. We will return the beginning plus our new base plus end. Sounds good? Let's try to run this. Okay. No, it's not working fine. String object is not callable. Yeah, this is the error. Alright, so there was this stupid bases over here. So it's running just as fine. Let's try running this. Print. We are gonna be using our function replace base randomly using names, and then our string is gonna be atgcta. Let's run this and see what we got. We are getting atgcga. So T is changed to G. So atgctc, atggta, atgcca. So let's define the same function with a little bit of complex code, and this time we won't be using a lot of assignment statements. So def replace base randomly using expressions, and we will give it base sequence, base seek, and let's come to the body of our function. So our position is simply gonna be the same, rand int, and then it's gonna start from 0, and it will go to the length of the base sequence -1. And you know why we are doing this -1. Now our return statement is gonna be very long. So what we need now is we need base sequence, and we need the starting position, which is gonna be 0 to the position. Alright, then we will add the new base, and we get the new base by tcga, and we replace it with base sequence at the position with an empty string, and then rand in 0,2. Now we will add the ending, and the ending is going to be base. Okay, let's move to the next line. Alright, let's write this in the next line, then write this in the next line. Okay, so it's gonna be base seek and position +1 till end. So we will keep this empty. Let's run this. This function is defined really nicely. Okay, let's try a new example. Print replace using expression, then our base is gonna atgcta. Let's run this. We got atgcca. This T is replaced with this C. Let's run this again. ctg. So this A is replaced with this C. ctg-cta. So there is no clear-cut rule about how many assignment statements are there should be in a function, and how much complicated your function should be. In case of this function, something between these two extremes is gonna be very perfect. Let's take a look at a moderate function. Let's make a new cell and define replace base randomly and base seek. So position is gonna be same, rand int, and then it's gonna be 0 till length of base seek -1. We will keep the empty string over here, tcga dot replace, and then base seek position with an empty string. And what we will be returning over here is base sequence, and it's gonna be the beginning. So it will be 0 till position, and then we are supposed to add the new base, and new base is bases, then rand end, and it's gonna be 0 till 2. Let's add the ending, and ending is gonna be base seek, and this is going to be position plus 1, and we will go till the end. So this function is defined. Let's try an example. Print print replace base randomly. Let's try only T is this. Okay, so we got G, now it's replaced, C is replaced, A is replaced. So you can see that there are quite a few random replacements over here. Alright, now let's talk about a module that I installed myself, and the name of this module is BioPython. Let me show you it on website BioPython. You can install it yourself and then you can explore it. I will give you a very basic example of it. You can see over here how to download it, and they will also tell you how to install BioPython. You are supposed to use the pip to install this, and let me give you a very basic example of how this is gonna work. So from bio.seek, okay, if you don't know how I got to know this, that I am supposed to use bio.seek, what you will have to do is you will have to go to the documentation of BioPython, and then you can see over here that everything is described. You can see wiki documentation. This is the seek, and over here it's written that I'm gonna be working on the same example, and will let you know how this thing works. So from bio.seek we have imported the seek, and let's make a new cell, and let me tell you how you are going to make a sequence object in BioPython module. So in order to do that, we will name it my random seek, and it's gonna be equal to, we will have to use this function seek, and in the argument we will put our sequence ATGCT808080A GC. So our sequence is defined. Let's see what we get by this simple variable. We get this. Let's try printing this. It's saying that this is an object of sequence, my random sequence, and so now we got a sequence. Now let me show you the magic. So in this new cell over here, if we use the complement function dot complement, then it's gonna return the complement of our C. Now you can see that A is changed to T, T is changed to A, G is changed to C, and over here this C is changed to G. So it's taking the complement. You can also take the reverse complement. So we will write dot reverse complement. Now you will get the reverse complement of the same string. So now you can see that we were able to do several functions because of the BioPython module. Alright, that's all for today. In the next video we will be talking about Python files. If you have any questions, comments or concerns about this video, feel free to comment down below. Moreover, if you want to discuss something, you can check out our Bioinformatics guys community, which is a Facebook group. I will put the link in the description down below. If you want to know what I do other than programming, you can check out my blogging channel. Thank you very much for watching, and I will see you around in the next video.